today's lesson, you will need two fraction walls, one already cut up into pieces and the other left uncut. You can find a link to my template in my video description below. Please note that because this is a pre-recorded lesson, it does not replicate the exact format or full suite of Singapore mathematics pedagogy. However, it does apply the concrete pictorial abstract CPA approach used in Singapore mathematics teaching. If you would like your child to experience the benefits of Singapore mathematics taught by a Singapore-trained mathematics teacher, please email me at conceptuallab@gmail.com. Conceptual is spelled with a K as the first letter. Today, we're going to learn how to add unlike fractions. So first of all, we're going to start off by doing a bit of recap on adding like fractions. So I have 3/5 on the left here and 1/5 on the right. If I want to add 3/5 and 1/5, we can see very clearly that you can either count the number of pieces if you have fraction tiles available, all right? And it would just be simply 3 pieces of fifths plus 1 piece of fifth that will give you 4 pieces of fifths. Okay, you can see very clearly over here, there are 4 fifths. Now, I have 3/8 on the left and 2/8 on the left, and I want to add them both together. So 3 pieces of 8 plus 2 pieces of 8, obviously we are going to have 5 pieces of 8. All right, so this is something you would have learned in the previous lesson or in grade 2, adding like fractions. Now we're going to look at how we can add unlike fractions. We're going to start off with this very simple example. Simple because these two unit fractions are very familiar unit fractions. Okay, so obviously I have half and a quarter. I want to add these two fractions together, but can we actually add them both? Why do you think we are not able to add them both together? Can we just say, oh, half plus a quarter, since there are 2 pieces, it will be 2 halves, or since there are 2 pieces, it could be 2 quarters. Do these two fractions add up together show you 2 halves? Now, how do 2 halves look like? 2 halves are going to look like this, right? Maybe I should bring that out here. So 2 halves are going to look like this. If I add half and a quarter, will they look the same size as 2 halves? No, right? It's obvious it's not. And would it be 2 quarters? So a quarter looks like this. Will a half and a quarter, if I were to put them together, would half and a quarter added up together look like this? No, right? It's going to look bigger than 2 quarters, all right? So none of these answers are actually correct. So what do we have to do in order to add these two unlike fractions? They are unlike because they don't look alike. They are not the same size. So what I want you to do is I would like you to pause this video and try to figure out how we can actually add these two unlike fractions. I wonder if you have figured out how we can add these two unlike fractions. So if you have your fraction tiles, looking at half, are we able to make half have same size pieces, I'm not saying make half the same size as a quarter, but within half itself, are we able to have a few pieces being cut up? All right, so do you think we can cut half up to have the same size as a quarter? If you still have your fractions tiles or fraction wall, I want you to use a ruler and look at which other fractions can have the exact same size as half. So the fractions do not have to be unit fractions. It could be, for example, 2/5, 3/4, okay? Which other fractions will have the exact same size as half? So you will see that 2/4, 3/6, 4/8, 5/10, and 6/12, they all have the same size, or they can make the same size as half. So what are these fractions called if they have the exact same size? We can say that half is equals to 2/4. Half is also equal to 3/6. We can also say 2/4 is equal to 3/6. Okay, is equal to 4/8, is equals to 5/10, is equals to 6/12. So any of these fractions, they are equal to each other because they have the same size. So going back to half plus a quarter, and I asked if we could cut half into equal pieces of quarters, okay, you would have noticed we can actually cut half into 2/4. Okay, so I'm going to pull these 2/4 out and put it over this half, and yes, it fits perfectly. So in other words, we can also say that half can be changed to equivalent fraction. You learned this in one of the previous lessons. All right, half can change to 2/4. Will a quarter need to change? No, it's already in the size that you want to use to add. So we will just write a quarter as is. 2/4 plus 1/4 will give you 3/4. All right, so this is how we add unlike fractions. We have to change one of the fractions into equivalent fractions to have the same size pieces as the other fraction. Okay, let's look at another example. The next one we have here is 1/3 plus 1/6. So we want to add, again, two unlike fractions, two fractions with different size. So you can't add them and call them 2/6 or 2/3. All right, you know 2/3 or 2/6 are not going to look anything like a third and a six put together. All right, so what do we have to do? We have to look at a third and ask ourselves how we can make a third have the same size pieces as a six. So using the fraction wall again, so this is a third. Okay, this is where a third ends. We're going to draw a line to find where a third is also equal to, or to find out which other fraction will make a third. So you see 2/6. So you can see 2/6. All right, remember we are adding 6. So if we are adding 6, then we want to turn a third into 6. All right, so that they have the same size pieces. You're not going to choose 9s because you are not going to change your 6 to 9s, all right? So we will change a third into, how many pieces of 6 can a third fit? It can fit 2 6, right? So we are going to add 2 6 to 1 6. And what is 2 6 equal to? 2 6 is actually equal to 1/3. All right, 1/3 and 2 6, they are equivalent fractions. So now that we have 2 6 and 1 6, we can just simply add them together to get 3 6. Right, 3 pieces of 6. So the answer to 1/3 plus 1 6 is 3 6. All right, now instead of adding unit fractions like half, a quarter, a third, and a sixth, I'm gonna ask you to try adding a third and 3/4. So how do we add a third and 3/4? Do you think we are able to make a third have the same number of pieces with the same size as a quarter? Can we fit a number of quarters in a third? No. So if we are not able to cut a third into quarters, we have to think of another way to add a third and 3/4. Okay, we cannot just simply say, oh, 1 plus 3 is 4. We can't say 1 plus 3 is 4 and then 3 plus 4 is 7 and say it's just 4 7. You can see over here it's not going to be 4 7s. Okay, so these fractions of third plus 3/4 are not going to look anything like 4 7s. Look, 4 7s look like this. Okay, if we were to put 3/4, if I were to put 3/4 over here and a third over here, okay, can you see it's nowhere looking like 4 7s? All right, so that's the reason why we can't just simply say, oh, it's actually that. Now, what if instead of asking you to add unit fractions like half, a quarter, a third, a sixth, now I have 2/3 plus a quarter. Can we fit, or can we cut a third or 2/3 into pieces of quarters? Do you think that will work? Will 2/3 be equal to a number of quarters? Let's explore. So you take your fraction tiles and try to see if it fits into 2/3. So obviously, as you can see over here, if I were to put this over here, it's going to be more than 2/3, right? So in other words, we are not able to change 2/3 into quarters. So what do we do in a case like this? So this is why using your fraction tiles is good to explore how we can add unlike fractions like this, okay? When we can't change the denominator of thirds or quarters into the other denominator. So what's going to happen is I'm going to join 2/3 with a quarter. Okay, so this does show the total, but as you can see, we are not able to write a total fraction for 2/3 plus a quarter. So take your 1/3, no, take your 2/3 and a quarter. I want you to hover over some of these fractions and see what 2/3 plus 1/4 is actually equal to. So obviously it's not 1/2. Let's try halves. Is 2/3 plus 1/4 equal to 1/2? No, it's not, okay? Is it equal to any of the thirds? Obviously not, okay? So go down the fraction wall and see if it matches any particular fraction. Not 6, 7, nope. 8, nope. 9, very close, but not yet. Could it be 10? Now let's try the last one. Does it fit perfectly into 12s? Actually, it does. Right? So if it does fit perfectly into 12s, okay, and I'm going to put this over here to help you see the alignment. So if I were to use a line, and I draw a line from here upwards, straight vertically up, do you see that 2/3 plus 1/4 is equal to this amount of 12s? And how many 12s is that? It's actually 11 12s. So how do we go about finding 11 12s? Can you see that 4 12s form a third? I'm going to bring this back up there again. Oh, again, it has got to do with equivalent fractions. Remember, every fraction has its own equal. So in other words, we can say that a third is made out of 4 12s. So 2/3 altogether is made up of 8 12s. Altogether is made out of 8 12s. 2/3 is 8 12s. All right, from this fraction wall here, 2/3 is made out of 8 12s. So how do we get from 2/3 to 8 12? 2/3 we have essentially multiplied by the numerator and the denominator by 4. Okay, why? If you look at the fraction wall over here, okay, a third can be cut into 4 equal pieces of 12s. Okay, so 2/3 will be 2 times 4 pieces of 12, which gives you 8 pieces of 12s. So 8 12s plus how many 12s will make a quarter? So a quarter over here is made out of 1, 2, 3 pieces of 12s. So what have we done to a quarter? We have actually cut a quarter into smaller pieces of 12s. So that's why we multiply by 3. Okay, it doesn't mean that a quarter is being turned into 3 pieces of quarters. When we multiply by 3, the numerator and the denominator, it is telling us that we are cutting a quarter into 3 smaller pieces to turn it into 12s. So when we add them up together, we will still have 8 12s plus 3 12s is 11 12s. Okay, so if you count over here, it does add up to 11 12s. So this is how we can add unlike fractions that have different denominators and we are not able to fit the smaller piece into the fraction with a smaller denominator. Remember, let's try one more example with fractions that have unlike denominators. Let's look at one more example. So I have over here 2 unit fractions again, okay, but they're unlike fractions. We have half and a third, okay. Do you think we can fit a third being the smaller piece into half and have another third fit into half? No, right? You can see that if we were to put another third, it's going to spill out of the half. All right, so we can't cut half into thirds, but we still need to add them. We still need to find the total fractions of half and a third. So what we're going to do will be the same as what I did for 2/3 plus a quarter. Let's join a third to half. So this is the total, okay, but we don't have a total fraction for half and a third yet. So what we're going to do is I'm going to place them over here first. Use your ruler, okay, and maybe put your ruler vertically to form a straight line upwards, okay? And we are going to move half and a third on this fraction walls. I'm going to move half and a third upwards on along this line, okay? Making sure that the end of a third aligns with this long line. So can you already see that half plus a third is equal to 10 twelves? Do you notice that? Half plus a third is equal to 10 twelves, okay? So 10 12 is an answer for half and a third, but I want you to find another answer because there's actually another answer for half plus a third. So try sliding this upwards and tell me what fraction is half plus a third equal to as well. Do you notice it is also equal to 5/6? Okay, it's equal to 5/6. See, this is exactly in line with 1, 2, 3, 4, 5, 6. Okay, so if that's the case, it actually means that both half and a third are able to be cut into equal pieces of 6, as you can see from this fraction wall. Okay, so half is equal to how many 6? Half is equal to 3/6. So we're going to write 3/6 below half. Okay, but how do we change half to 3/6 in numbers? We have essentially cut half into 3 pieces of 6, right? So that's why we multiply by 3 for the numerator and the denominator. Okay, and then a third is cut into 2 equal pieces of 6. So a third cut into 2 equal pieces of 6. So we will write 1 times 2, numerator times 2, denominator times 2 to get 2/6. And then we just need to add 3/6 and 2/6. We get 5/6, which was what I showed you on the fraction tile just now. Okay, so I'm going to show you one more time. This fraction wall is so useful. All right. So what we have to do when we add unlike fractions or subtract unlike fractions is we have to make sure both fractions or however many fractions you're asked to add, if they are unlike, we need to change them into equal size pieces. And equal size pieces means they need to have the same denominator because the denominator tells you the size of each piece in that fraction. All right, so make sure we change both fractions into equivalent fractions with the same denominator. And after we have changed both fractions into equivalent fractions with the same denominator, then we can add, just like how we add like fractions. Now, let's look at these two questions over here. When we add a half and a third, we end up with 5/6. This denominator is so different to the denominator of 2 and 3. Likewise, for 2/3 plus 1/4 equals to 11/12. We know that we have to change half and a third to equivalent fractions with the same denominator because we need to make sure the pieces are of equal size before we can add them, like adding like fractions, all right? But how do we know what denominator we need to change to if we don't have our fraction tiles? Take a look at the numbers that half and a third are being multiplied by. Take a look at the number 2/3 and a quarter are being multiplied by. Half, 1 is multiplied by 3, 2 multiplied by 3. For a third, 1 is multiplied by 2 and 3 is multiplied by 2. Do you see these numbers anywhere between these two fractions? Likewise over here, do you see 4 and 3 in any of these two fractions? You probably will have noticed to change from half to 3/6 and a third to 2/6, you would have taken half times 3, which appears in a third, and a third times 2, which appears in half. Likewise, to change 2/3 into an equivalent fraction with the same denominator as the equivalent fraction of a quarter, you are taking 2/3 times 4 in the numerator and 4 in the denominator, which comes from the denominator of a quarter. And then to change a quarter into equivalent fraction with the same denominator as the equivalent fraction of 2/3, which is 8/12, you have to multiply the numerator and the denominator by 3 of 2/3. So if we have a question such as 2/5 plus a third, and we don't have our fraction tiles, we know that we need to change 2/5 and 1/3 to fractions that have the same size pieces. So to do that, we are going to cut 2/5 into smaller pieces, okay, which will be multiplying by 3, which is a denominator of a third, and then 1/3 times 5, which is the denominator of 2/5, like the examples up here. Okay, then we will have equivalent fractions for 2/5 and 1/3 with the same denominator. And then we just need to add 6/15 to 5/15 to get 11/15.